Hello there once again. You are welcome to your favorite mathematics YouTube channel, Mathematics by Abu Zainab, a special channel created where you and I are aiming to demystify mathematics and tackle headlong once and for all the phobia associated with this all important topic. In our last lesson, we looked at the topic number base and we learned the basics of number base. We take it from there right away today by looking at conversions from base 10 to other number bases. Today, we are going to look at conversions from base 10 to certain bases: base 2, base 8, base 12, that's duodecimal, and base 16, that's hexadecimal. With just one example, we aim to show that this conversion is actually the same process. Example, let's convert the number 249 to 1. Base 2, that's binary. 2, octal, that's base 8. 3, duodecimal, that's base 12, and 4, hexadecimal, which is base 16. From our last lesson, we actually converted from this order basis to base 10. So we are taking the reverse process today. And come along and see how it goes. The very first one is converting base to base 2. Remember, the last lesson I did mention that base 10 can be written without necessarily putting the base as a subscript. You can write base 10 either by putting the figure 10 or the word TN10, or we just all along leave it without putting anything there. It's only permissible for base 10. So now, how do we convert from a base 10 number to these several bases? The procedures are quite similar and seamless. Let's go along. So you have 249 to base 2. The rule is that the base they are converting to will be your divisor, what you divide with. So we are converting to base 2, which is binary. We have 2 here, and we divide. With every step of the division, we must not forget to write the remainder, because that's essentially what we need as our answer. So 2 into 1, 2 in 4, 2, 2 in 9, 4, remainder 1. Then again, 2 in 12, 6, 2 in 4, 2, remainder 0. Then 2 in 6, 3, 2 into 1, also remainder 0. 2 in 31 is 15, remainder 1. Going further, 2 in 15 is 7, remainder 1 again. 2 in 7, 3, again, remainder 1. 2 in 3, 1, remainder 1. And lastly here, 2 in 1, 2 cannot go in 1, so we have 0. Remainder, whatever is on top of the 0, we bring down here. And the moment we get to 0, that's the end of the computation. The last stage, however, is writing our answer from down upwards. So we're having 249 in base 10 is equivalent to 1, 1, 1, 1, 1, 1, 1, 1, 1, then 0, 0, 1. Don't forget, you must put base 2. And that's the conversion of the number 249 in base 10 to base 2 number, which is quite easy, I believe. Right away, we take the second example, which is still the same number 249 converting to base 8 octal. So we have 249 this time around to base 8. As I mentioned earlier on, the base that we are converting to becomes our divisor. So in this case, 8. So 8 in 24 is 3. 8 in 9 is 1. Remainder 1. Then again, 8 in 31 is 3, which is 24. Remainder 7. And 8 in 3 is not possible. We can't have, so we have 0. Don't forget, I mentioned that the number above the 0 automatically comes down here, which is 3. And remember, to get to 0, that's the end of the process. So the answer again is taking upwards from 371. So that means 249 in base 10 is equivalent to 371. Don't forget base 8. It's very important. Many mistakes that students are many students make that mistake of forgetting to affix base here, which means you're writing 371 in base 10, and that is wrong. So you have to put the base there, base 8. Okay, now we move to duodecimal, which is base 12. So for duodecimal, we are still converting the same 249, this time around, to base 12. So we go 12 in 24 is 2, and 12 in 9 is 0. 12 cannot go in 9. Is 0, remaining what? That same 9. In other words, 12 times 20 is 240, then plus 9, 249. So again, we go 12 in 20 is 1. 12 can only go once in 20, leaving the remainder of 8. And lastly, 12 in 1 is 0, remaining 1. Don't forget, the number above 0 automatically comes there. So we have 189. In other words, 249 in base 10 is equivalent in value to 189 in base 12, which is fine, quite easy, I believe. And the last one there, we got the same 249 this time around to base 16 hexadecimal. So 16 in 24 is 1, remainder 8. Then we attach the 8 to 9, that's 89. 16 in 89 is 5, which is 80, remainder 9. That means 16 times 15 is 240, and then plus 9, 249. Then lastly, 16 in 15 is quite impossible. It's 0. Remainder what? 15. We can't possibly write 15 here because in base 16, remember, 15 is F, letter F. So we have remainder F, which means it's 15. And once again, once we get to 0, our work terminates. So the answer is written upwards, meaning 249 in base 10 is equivalent in value to what? F9 in base 16. This is not a value that people like to see. F9 means failure, but that's not the meaning in this case. It's simply F9 base 16. And that's been the end of our conversions to base, other bases from base 10. So today we have looked at how to convert from base 10 to other bases, and we have shown that the processes are the same all through, which basically means division by the bases we are converting to. And at every successive division, we don't forget to write our remainders, because it's at the remainders that we write from down upwards. And that's the end of our lesson today. I hope that you enjoy it much as I do. And if you are looking forward to our next lesson, please don't forget to subscribe, share, turn on your notification button so that when our next video drops, you'll be the first to know. Thank you and God bless.